Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello everyone, hello students. So the topic for today is power transmitted through pipes. When a fluid flows through pipe, it has certain purpose. It is not flowing just for the sake of it. It is having some purpose, so we need to calculate the power that it can transmit and the power that it is carrying along with it. So it's very important to calculate power, and when you calculate power, what are the factors that you need to incorporate? What are the factors that you need to consider on it? We'll be discussing all that. The factors that you need to consider is the length of the pipe, the diameter of the pipe, and the weight of the water that it has to carry, everything. And next, we'll be seeing what is the condition that uh, the fluid should have, or the system should have, so that the pressure, the power developed is maximum. So we'll be driving on condition which will give us the condition for maximum power generation. So it's all about power calculation, power generation, the formulas of power that we'll be studying in this topic. So the formula for power is nothing but rho G Q H available. So H available is nothing but the head that is available. So the gross head can be anything. It can be 500 meters or anything. But what we are interested in is the available head. The gross head minus the losses will give you the available head. So you need to subtract all the losses that is happening, all the minor losses, all the major losses, and after you subtract all the losses, you get the value of head available. And head available, if you multiply with these quantities, you'll get the power that it will develop. So head available is nothing but the total head minus the head loss because of friction. So as of now, we are neglecting the minor losses. I'm considering only the major loss, that is loss because of friction. So the total head minus the loss because of friction will give you the available head. In fact, it will be not the available head, it will be the available head will be if you subtract all the minor losses also, but as of now we are assuming the minor losses to be zero. So we've already seen the formula for HF, that is Darcy-Weisbach equation. So what we'll do here is we'll write Q, that is discharge in terms of velocity. So now we can see that the power is function of velocity. You have to differentiate this equation with respect to velocity and equate it to zero, because we know that for maximization or minimization, derivative has to be taken and it has to be put zero. So what we've got here is the condition for maximum power transmission. So HF is equal to H by 3 is the condition which has to be satisfied so that the power transmitted is maximum. So HF is H by 3. So what we have done here is we have calculated power in terms of velocity. It's function of velocity, so you have to differentiate with respect to velocity, and after differentiating you have to put it 0, and after you put 0 you solve the equation, you get the value of HF as H by 3. So this is a condition which has to be satisfied by the flow so that the power transmitted by it is maximum. So that was all about this topic. I hope you all have understood the condition for maximum power transmission and also the formula for power that it will develop. Thank you.